Hey guys, so quick video just to kind of give you an idea of what base 10 means. You've probably heard this said since elementary school. We have a base 10 system and our place values are built upon that idea. And maybe you haven't really understood what that means. And now that we have an understanding of exponents, let's take that a bit further. So I'm just going to come up with a random number here. Let's go 5,283 and let's go with 12 hundredths. And what I want us to notice is the actual place values within this number. And so we'll do the old columns that you probably saw from elementary school. And of course you were told that this is the hundreds place, the tenths, the ones, the tens, the hundreds, the thousands. And so that's worth, this 5 isn't worth 5, it's worth 5 1,000ths. Well, what's interesting is that's all expressed using the base of 10 in exponents, and that's why we care. So I'll draw a line here on the bottom. So this is 10 to the third power, which happens to be 1,000. The hundreds place is 10 squared, which is 100. This is the tens place, 10 to the first. Oh, and you know why anything to the 0 power is 1. It has to do with some patterns we looked at in class, and really, if you extend those patterns, it has to do with the fact that 10 divided by 10 is 1. So we know this is the ones place. Now the negative exponents we looked at. And so that's how our place value system works. As we go towards the left, we get infinitely large powers of 10. So the next one will be 10 to the fourth, 10 to the fifth, and so on. And as we go infinitely to the right, the powers get smaller, but they're always integers. We're not worried. We don't have place values in our base 10 system where they're like fractional exponents. So we're not having. I guess you could say we don't have place values with like radicals. But as we move to the right, as they get more and more negative, we know that this is also 10. Let me rewrite this here. I want to write this a little clearer. We know this is 1 over 10 squared, or 1 over 100, or 100th, so the hundredths place. This is 1 over 10, or the tenths place. This is the ones, the tens, the hundreds, and the thousands, as we said. So what's the big idea? What's the point here? Well, the base of all these exponents are 10. And so an interesting question that I want you to consider is what happens to numbers if the bases aren't 10? Do those numbers still express the same value? And if not, why? And what values would they express? And why do we even care? And that's some of the questions we're going to be looking at in class, and then we're going to be extending our knowledge of base 10 to use scientific notation. So I've got one more slide for you in which I kind of pose some questions, give you one small example, and I'm just going to ask that you, after watching this, complete the homework that's been posted on the website. So on the website, I basically give you a number, and I say this is in base 6, and can you write it in base 10? But it's just kind of a straight-up question. I ask you to do your best. I'm not going to necessarily show you how to do it now. I'm just going to give you a little more information so maybe you can figure it out. So what does a number in another base even mean? So let me write a number in base 5. By the way, if you want to say a number's like base something other than base 10, you can just write it a little small subscript. We don't bother with our numbers because we all assume that they're base 10. But what this means in particular is this is still the ones place. But now this is the 5's place, this is the 25th place, and this is the 125th place, if we were to break this into columns again. And the reason I knew that is because I knew the base of my exponent changed to 5. Or I should say the base of my power changed to 5. And so this 1 is no longer worth 1,000. It's worth 1/125 because 5 cubed is 125. So this is 1 times 125 plus 4 times 25 plus 0 times 5 plus 3 times 1 because 5 to the 0 power is 1. And so this value, this number, if we were going to say what it was in base 10 system, is we would actually calculate all these out, add them together, and that's what this number actually represents in our base 10 system. So 225 plus 3, so 228. So this really big number, 1,403 in base 5, is only worth 228 in our base 10 system. That's really interesting. And we're going to look at this much more in depth in class. I just want to give you kind of a basic idea of what base means, base 10. It means the base of the values of our place values is 10. And if we change that base to 5, we can change that base to any number we want. The value of the number that you see, these digits, those change. Thanks for watching.